नमस्कार मित्रों। उम्मीद है आप सब अच्छे होंगे और इस लॉकडाउन पीरियड में इस नए मोड ऑफ टीचिंग का पूरा लाभ उठा रहे होंगे। अब तक पिछले कई वीडियो हमने रिफ्लेक्शंस के बारे में देखे और उनके बारे में काफ़ी कुछ मैंने बताने की कोशिश की। इन द कमिंग वीडियोस or video lectures, I will tell you about the refraction through the lenses, spherical lenses, and we will come to know about the image formation by spherical lenses. What are the important rays to be considered for drawing the image formation cases in lenses? So, dear learners, in this lecture, we will discuss about the image formation by convex lens when the object is placed at different positions. The first case I am taking here, when the object is placed at infinity, and then how the image is formed. We are very much concerned about the three characters of the image. First is position, second is nature, and third is size of the image in comparison to the size of object. So this is our convex lens. Principal axis of the convex lens. This is optical center. This is focal length, focus. This is the position of focus. Since object is at infinity, we are taking any two parallel rays originating from the principal axis, from the object, and parallel to the principal axis. After being refracted, they will pass through the focus. So position of the image is the first is position at F on opposite side. The second feature is nature. It is real at inverted. The third feature is size, and it is of point size. The second case of image formation is when the object is placed it is beyond 2f. When object is beyond 2f, how this image is formed, what will be its position, that we will learn by this ray diagram. This is our convex lens having principal axis like this. This is optical center, and this is focus. Here also it is focus. And this is 2f, and let the object is lying beyond 2f. As usual, the first ray we are taking parallel to the principal axis. This will pass through the focus after being refracted through the convex lens. The second ray we are taking passing through the optical center and this ray will go straight without deviation. So in this case you can see the image is formed little away from the focus, lying between f and 2f on opposite side. So position is between f and 2f on opposite side. Nature is as it is, real and inverted, and size is smaller than the object. In the same sequence, if we bring the object near to the lens, then the next location would be at f. Object is at focus 2f. In that case, if object is placed at 2f, then where the image is formed, that we'll understand by the another ray diagram. As usual, we have taken the convex lens. This is axis, principal axis of the lens, optical center. This location is f. Here also it is f. Then it is 2f. This side also 2f. So if object is taken at 2f, then again we will take the same two rays passing through the optical centers, and one is parallel to the principal axis. The ray which is passing through the optical center goes straight, you can see in the diagram, and the ray which is parallel to principal axis will pass through the focus. So this is object AB, and here it is image A dash B dash. So where the position of image is at 2f on opposite side, nature is again same, real and inverted, and size of the image is same as the object. Whatever is the size of object, the same size of image will be formed here. So this is the third case of image formation. Now if we move object further closer to the lens, where it will be, the next position is between f and 2f. The same ray diagram we will draw for this case also. This is the convex lens.
principal axis. This is focus f. Here also this is 2f, double of focal length. Now the object is lying between f and 2f. The first ray, as it is parallel to the principal axis, after being refracted through this convex lens, it will pass through the focus. The another ray we are considering, as usual, passing through the optical center, and this ray goes straight. So you can see this time the image is formed at this location, which is beyond 2f. So first characteristic is position beyond 2f on opposite side. The second feature is nature, real and inverted, and the third feature is size. It is bigger than object. So in that way, you can see, as we are moving object near to the lens, the image is shifted away from the lens. If we move the object further closer to the lens, the next location would be focus. So we take, in the next case we take object at f. When object is at f, we have to see where the image will be formed. So taking same principal axis, focus, distance is taken same on both the sides. So now, if object is at focus, then where the image is formed, it is quite interesting and challenging as well. If you take the first ray as it is parallel to principal axis, it will pass through the focus. The second ray, if you take passing through the optical center, then you can see these two rays are parallel to each other, so they will not intersect at any point. In that case, how would we locate the image and how would we say about the nature of image? For this case, we will follow the concept of reversibility. The ray which is parallel to principal axis passes through the focus, and the ray which is passing through the focus becomes parallel to principal axis after refraction through the lens that we had seen. So since these two rays are not intersecting, so if we take the case when the object was placed at infinity, the image was formed at focus. Likewise, if the object is at focus, the image is at infinity on opposite side. So the first property is discovered. The second one is as it is real and inverted. Then the third property is highly enlarged. It means the size of image would be very large in comparison to the size of object. If we move object further closer to the lens, then it would be between F and O. So the next location of object would be object between F and O, that is focus and optical center. So how this image is formed, that also we will learn by using the ray diagram. As it is, this is our convex lens, principal axis of the convex lens, optical center, this is focus. On this side also, this is the location of F, and the object is lying between F and O. As usual, the first ray will be taken parallel to principal axis, passes through the focus after being refracted, and the second ray we are taking passing through the optical center, that goes straight. So you can see these two rays will never intersect on opposite side because the distance between them or separation between them is increasing. So if you produce them backward, you will see these two rays will intersect at some other point, and that would be the location of image. So the nature of image here is not real. It is not really forming. It is formed when we produce the refracted rays. So position is where? On same side. Wherever the object is placed, on the same side the image is formed, and it would be beyond F, anywhere beyond F. The second one nature is virtual and erect, and the third property is about size, and the size is enlarged. So you can see in the last case the nature of image has been changed from real and inverted to virtual and erect. So you can see all the cases once again how these images are formed and how can we draw the diagrams correctly. In all the diagrams we have taken two incident rays originated from the object parallel to principal axis and passing through the optical center. If you have taken the distances properly, the location of focus on both the sides of the optical center, the position of image will come automatically at the real position wherever it should be. So In this lecture, we came to know about the image formation by convex lens when the object is placed at different locations. Thanks for watching this lecture. I hope it will help you to learn the things. Keep watching, keep learning in the next video.